In this short video, we'll look at the keyword using and two variations of his usage in C++. First of all, the first option is something we already seen in the previous video, where we say using namespace std, and this imports the namespace so that we can use it directly within the current code. There is another important second way of using the keyword using to create your own name for a particular data type. In a way, you parameterize the data type, and that's useful for later on modifying your code without having to go all over the code and run the risk of making mistakes and so on. In this particular case, you have using my type equal int, which means the word my type in this context really means int. And then, for example, if I want to create an array of integers, I can create the type my array, and it's my type open, close, square brackets. And so this would be like int and open, close. So this is an array of integers. And the nice thing is that now I can start using those words instead of hard coding the basic type, and that later on can be changed. So let me see with a practical example from the previous code how this could be useful. So this is a piece of code that we saw before. I test an array that creates two arrays, one of 3 elements, one for integers and one of 5 integers, and then it calls the print function for an array as described here. Notice that here I have the int basically hard-coded everywhere. You can imagine how this propagates if you had a larger piece of code. But the code then is hard to modify. So let's say that I run this code. So I've created those two arrays, 5, 10, 15, and it gets printed here to 4, 6, 8, 10, and it gets here printed to 4, 6, 8, 10. So the code works correctly. But if I were to start using, for example, floating point numbers, what would happen is that because the types are hard-coded, here, for example, I get a warning. So technically the code run, 5.5 gets assigned to an array of integer. So it gets converted. So it takes more to modify the code, right? So here, even though in my input I have 5.5, they get cast to an integer, and still I get 5. So if I really want to modify the code here, I would have to do a lot of more work because I have to go around and change the type here, and then the type of the function that prints, and so on. Now, to address this flexibility issue, which is actually very important when you do real coding in larger projects, one way to do that is to use the keyword using. And and I'm showing here already written just to do it quickly. So here, as I showed in the slide, you have using my type. Now it's a double. So actually, let me put it back to be an int. So this would be exactly the same code as before, right? Using my type int, using my array, and so on. And so here in the code, I parameterize everything based on my array. And so that's based on int. So this version with the int would have would work as expected in this case with a set of integers. But now if I introduce a float, as you see here, now as I introduce a float, let's see, recompile. Here we have the usual warning because of the casting. So I can run the code, and then you can see that it got casted for the same issue. What I can do now, though, simply replace here double. And so first of all, you see immediately that I don't get any warning anymore. So this has been accepted as a double because my array now, it's an array of doubles. And so when I run the code, I actually get the correct behavior that 5.5, 10, 15 gets printed correctly. So as you can see, by just changing a single type there, the change gets propagated everywhere. And so this is a very convenient and elegant way to write code that later on can be cleaned up and modified and used in a much more general setting.